So on Friday, we started talking about radical expressions and nth roots of stuff, and we had some rules back on that core concept that we'll want to revisit here again. But um, I think that when we got through example 2, this gives us a chance to approximate expressions with rational exponents. Everything that we had up here was like a perfect root before, up in the example 2. So in example 3, guys, I'm going to say, let's use our calculator for this right here to evaluate these. And it says round to how many decimal places here, guys? 2 decimal places, okay? Guys, I think what would be important is to write this in some kind of a radical form first. So, guys, I have 7 to the 1/4 right here. So when I do this right here, this is going to become a root of 7. What's the index going to be out there in the front? Not 1, but the 4 will be an index there, right? And then I'm going to put a 1 out here. So the part I would need to evaluate my calculator first, and some of you guys that were gone, excuse me, on Friday might need some help with this. But what I do is I type in 7, and then I'm going to hit my second key. You guys in your calculator, you guys see this button right here that says the Y root of X? Ouch, I hurt. Y root of X right there. Did you guys hear that? Yeah. Okay. That's the one you're going to hit. And then what root of 7 do we have to have here first, kids? 4th root. So I'm going to hit yth root of X and then go 4. Okay. And then we're going to take that to what power, guys? Then we need to go X to the Y to the first power. Okay. Raise that to the first power now. And we get about 2 places. If I was rounding, what would that be, guys? So about 1.63. Okay. So I get about 1.63 there for this one. Okay. So I'll say this is approximately... Now, here's the deal on this, guys. We need to revisit our core concept. What kind of root did you have, or I'm sorry, what kind of index did you have up there in parentheses? Was it odd or even? It's even, which means that if it's an even root and you got a positive value underneath the sign, this could either be positive 1.63 or what? Could be a negative 1.63 as well. All right, so I'm going to call this or approximately negative 1.63. Okay. All right. How would you write 10 to the 2/5 power in radical form, kids? What would your index be? 5. So the 5th root of 10, and then raise that to what power, kids? Okay. So let me show you this real quickly in calculator again. All right. So we're going to go the 5th root of 10. So I'm going to type in 10. I'm going to go the yth root of X, and it was 5th, right? And then what power am I going to raise that to? Was it the 2nd? What do we get for a value there? 2 places. Okay. All right, so now here's the deal, guys. Another way you could do this, if you wanted to, in your calculator is this. You could just type it in like that. You could raise it as 10. And then you see this X to the Y button, raised to a power. I could raise it to then in parentheses, I could just go 2 divided by 5 like this. See how I've punched in there? 10 raised to the 2/5 power right here, or 2 divided by 5. Yeah. Okay, let's see what we get for that again when I hit OK. What do we get again? So you can punch it in as is, okay? If you're going to use it as an exponent, like you're going to type in 6 to the 1/3 power, make sure you put what around that 1/3 power? You put parentheses around that, okay? Hey, so I want to ask myself on this again. Notice my index right here, guys. Is this odd or even? So we're only going to have how many solutions? 1, okay? All right, same thing here. What's the index for this, kids? 3. So I can only have how many solutions here? 1, because it's an odd index. So we're going to go cube root of 11 first. So hang on a second. And then I want the cube root of that. And I actually have a cube root button right there, but I'll go with the yth root of X and hit 3 again. And then what power do we need to raise that to now, kids? I've got the 3rd root of 11. What power do I need to raise that to in that example? 2nd? Yep. Okay, I get 4.95 for that. Okay, got 4.95 for that. So quick question here, guys. Whoops, wrong one. In this right here, kids, I think the ones that were here Friday are pretty confident punching stuff in their calculator. Who was gone again Friday? Just Amelia, Gracie, Hamed. You guys will probably want to show me your calculator here in a little bit, and I'll show you how to punch that in. You guys cool with that? We'll get through with this. Okay. All right, guys. Well, let's start talking here. It says solving equations using nth roots, and I really believe that if there's any, I think there's something that's pretty important right here. It's probably this one right here. So I'd put a star by this if I were you. Okay, I'd probably put a star by this if I were you. It's pretty important. Okay. Here we go. Guys, right here it says we have 5x to what power? Third power is equal to 320. Okay, so guys, the way I'm going to do, I'm going to rewrite this here first. I'm going to call this 5x to the third equals 320. Now, guys, what we're trying to do is we're trying to solve for x. So the first thing I should do in something like this is divide by how much, you think? 5. Divide by 5. Okay. So the thing that we're going to talk about here is this. We're going to end up with x cubed equal to, let's see, 100 and... This should be 64, shouldn't it? Okay. So my friends, right here, when we get done with this, when we solve equations using nth roots right here, we have x to the third power is equal to 64. Now, guys, we use roots to undo exponents like this. So if I have something to the third power, which root is going to be the inverse of the third power? Cubic root, right? So we're going to take cube root of both sides now. So right here, we go cubic root of x to the third. If I do that to the left, I need to do it to the right there, okay? So the cube root of x to the third is just simply going to equal x down here, okay? Anybody know the cube root of 64? 4. Yep. And if you weren't sure, I would just go right here. I would just go right here and be like, okay, well, I'll punch in 64, and I want the cube root of that. Turns out to be 4. Is it could it be a minus 4 here, guys? Why not? Yeah, because the index is, what kind of index, kids? It's an odd one, okay? Now, something like this next one right here, this gets a little trickier, okay? Find the real solutions of x plus 3 to the fourth equals 24. I need to check on something here real quickly. I want to see how they did it. Well, maybe I don't need to, okay? But what we end up with here, guys, is this. First of all, I got to get this x plus 3 alone in this. So I'm going to rewrite this one more time. Okay. To get rid of this exponent of 4 right up here, guys, what root would I have to take to both sides? Okay, so let's do that. Let's take the fourth root of both sides. Okay, you guys with me on that? Okay, what's the fourth root and the fourth power on the left going to do to each other? Okay, going to cancel. So do you guys agree that we have x plus 3 left over here? Okay, now we have to be very careful on the next part. Okay, and this is where some of those rules are going to start to come back to us. But guys, that fourth root of 24. First of all, your index up here, odd or even. And this value underneath here is positive, isn't it? So how many solutions is this really going to have? It's going to be positive and negative, right? So I'm going to go to my calculator. I'll go 2 places on this stuff. So I'm going to take which root here, guys? And that's about 2.21. Okay, so here's what we end up with. We end up with x plus 3 could equal 2.21. Or x plus 3 could actually equal what kind of 2.21? Okay, so let's solve the one on the left. What would I have to do to both sides? Subtract 3, right? So I get x is about, I've got that wrong. If I go 2.21 minus 3, anybody know that off the top of their head? Or is it too early on a Monday? I think it's negative 0.79. Yep. So x is equal to negative 0.79, or I can do this one in my head. If I subtract 3 more from negative 2.21, this would be negative 5.21. Okay. So you've got to be careful. Again, if you ever see this even index up here, a positive value right in there, you got to understand that that fourth row of 24 could either be positive 2.21 or negative 2.21. Okay. Guys, what questions have you got on example 3 and 4 right now? You might need more time with those at this point. Okay, well then let's roll on to this last page here. I think I have one more example left. Is that true? Yep. All right, let's talk here real quickly. Okay, example 5 is a real life application. So we got to be thinking either rational exponents or nth roots of something here. So let's talk about this. It says a hospital purchases a machine for how much? $75,000. That's a lot of money. Okay. The hospital expects the useful life of the machine to be 12 years, at which time its value will have depreciated to what? So in 12 years, this $75,000 machine's value will be worth $15,000. It says the annual depreciation rate R in decimal form is given by the following formula. R equals 1 minus S divided by C to the 1 over N, where N is the useful life of the item in years, S is the salvage value, and C is the original cost. So what's the annual depreciation rate for the hospital here? Okay. So we need to use this formula. They say the depreciation rate R is equal to 1 minus whatever your salvage cost is, how much it's worth after time, over the original cost, all to the 1 over N power. That's an S. That's an S. So let's see what we can fill in here, guys. We're going to have our rate equal to 1 minus. Help me out, friends. What's S? What's the salvage value? How much is it worth after 12 years? So this would be $15,000. What was the original cost, friends? To the 1 over N power, which would be 1 over, how many years did they use this useful life? 12 years. Okay. All right, let's punch some numbers in. I'm going to do the part in parentheses first. So we're going to go 15,000 divided by what first? Let's see what that is. What do we get there, guys? 0.2. Okay, so here we go, guys. We're going to come back to this. We're going to say this is equal to, that percentage rate R is equal to 1 minus 0.2 to the what power, kids? Okay, so help me out, guys. Would I take 1 minus 0.2 first, or would I do 0.2 to the 1/12th power first? Okay, so I'm going to do this right here. I'm going to go into my calculator. Watch how I type this in. I'm going to clear this out. So I'm going to go 0.2, and I'm going to raise this to this. So I'm going to hit this X to the Y button on the far left right there. Okay. And then I need to make sure I put 1/12 in there as a fraction. So what do I need to use around that 1/12? I'm going to hit parenthesis 1 divided by 12. Okay, what do we get for that, guys? 0.083. Something doesn't seem right here. You know, whatever. We'll go with it. Oh, I've got a wrong button in there. It says 0.2 times 1 divided by 12, doesn't it? Hang on a second. I'm going to go 0.2 x to the y. Okay, clear. Let me try this again. We've got a wrong number at 0.2. Something didn't look right there. There we go. 1 divided by 12. What do we get there, guys? 0.87, don't we? Okay, so about 0.87. So, guys, this is the same as r equals 1 minus 0.87. And 1 minus 0.87, anybody know it? Close. So the annual depreciation rate the hospital used would have been, what's 0.13 going to be as a percent, kids? All right, my friends. What do you think about this stuff? Pretty good? Okay. Peeps that were here on Friday, help out the ones that were gone on Monday a little bit if you can, with notes, getting caught up, at least getting stuff down. If you're confused about what's in example 1 and example 2, remember you can go right here on the 16th. It's got the video there, so if you want to watch that and hear what we had to say. We had a pretty short morning that day because it was a 2-hour delay, and I think I had some technical glitches that morning, so it's only about a, I don't know, 20-minute video if you want to watch that day. So, all right. Guys, back on the notes then. What questions about anything? Anybody have questions here? Middle of the room? Anybody middle of the room? Kids on the wall over there? Any questions so far? Okay. Well, let me do this then, guys. Let me stop this here.